Hello all, welcome. So today we are going to discuss about uh, knife bias classifier. Okay, suppose we have a random vector x which can take value from 1 to k, and there are d dimensions. Okay, so what is k? K is number of values for each feature, and d is total number of features. Okay, so we want to find a class conditional distribution p of x given y equals to c, right? So we have some assumption. The assumption is that the features are conditionally independent for each class level. So x1, x2, xd, right? This all features, this are independent to each other. This is our assumption for this naive Bayes classifier. This is also known by NBC. Okay, so if uh, they are independent of each other, then p of x given y equals to c and the class and the model parameter, we can write it as multiplication from 1 to d for each of the features. Okay, so you can understand this. I have written just p of x1, p of x2, dot dot dot, p of xd, right? So this all can be multiplied because we are trying to find p of x1, x2, x3, xd all happening together. So this is nothing but p of x. Okay, so the resulting model in the naive Bayes classifier um, is this. Okay, and there is one advantage of using this naive Bayes classifier, and these are uh, it is immune to overfitting. Next, if our features, if this x1, x2, x3, this all features are real value, then this probability can be modeled by using Gaussian, right? So what I am saying, if y equals to c, if this x, vector x, is real valued, then we can say this is nothing but equals to n xj mu jc sigma square jc, right? What is this? This is nothing but mean of features j in class C. Okay, and what is this? It's variance of feature j in class C. Okay, so uh, uh, but instead of real number, if the features are binary, that means the entire x can be represented as 0 0 1 1 0 up to d. Yeah, I have already said that x is nothing but x1 x2 x3 xd, right? So these values are taking either 1 or 0. This is taking also 1 or 0. This is 1 0. Okay, so if this is the case, then we can represent the probability, this p, using Bernoulli, right? So our p y given x and vector model parameter theta is nothing but j equals to 1 Bernoulli xj mu jc, right? And what is mu jc? It is the probability that the feature j occurs in class C. Okay, so and third, uh, see, first case was the feature is taking the real number. Second was the feature is taking a binary number, either 0 or 1. And third one, the feature is taking categorical numbers, or we can say categorical features. Okay, so xj will nothing but 1 to k. Matlab, it can take value 1, 2 or any number between 1 and k, right? So then p x given y equals to c theta. See, what this actually mean is, like, we are trying to guess what will be the new x, uh, what will be the new data, and we are trying to find its uh, cl classes, find to want to find about the probability given this model parameter and this class level. So this will be pi j equals to 1 to d categorical xj mu jc. Okay, where mu jc is histogram over the k possible values for xj in class C. Okay, so yeah, okay, so now we want to do the training of what? NBC, right? Naive Bayes classifier. So it is also known by model fitting, right? Computing MLE or MAP estimate of parameters meters. So what actually I mean, suppose uh, this is the parameter x, and we are trying to find theta hat, which will uh, be the best for the uh, our model, right? So we want to find this theta hat. This is done by MLE or MAP, right? So if there is only single data, then what will be our model, training model? Xi, yi, theta is nothing but, you see, there is also a level, right? With x, we are giving level uh, by knowing the where the model parameter is already given. It's given by yi by uh, multiplied by pi j p x ij theta j, right? This is for all j, right? So the probabilities of all the features and the level. Okay, so this is nothing but multiplication of pi c indicator function yi equals to c pi j for all c p x ij theta jc indicator function yi equals to c. So here whenever yi, that is the level, which is equals to c, this will be true 1, else if it is false it will be 0, and the entire this term will be 1 if it is 0. Similarly, this term will be 1 or 0 depending upon whether the level is c or not, because we are trying to find for all the c's, right? Taking the log likelihood, log likelihood in this term, we will get log p given the parameters, and this is d, which will be nothing but summation c equals to 1 to all c nc log pi c plus a term summation for all j to d or all c, and here the yi equals to c log p xij theta jc, right? This term I have already we have found from above mentioned term. Okay, from there we have just taken the log of the terms, right? But I hat c is nothing but nc by n. Okay, where nc is number of uh, elements of C classes and capital N is total number of elements, right? NC is nothing but indicator function yi equals to C, yi is the level and C is uh, the class name. Whenever this is true, it will become 1 and will add to total NC. Let all the features are binary, so xi and y to C follows Bernoulli's distribution. This is Jesse, and then MLE will be nothing but NJC by NC, right? So what I have said that then theta C hat is nothing but theta hat 1C, theta hat 2C, dot, theta hat 600C. Suppose there are 600 features, okay, and then there will be 600 for each of the C classes. This is nothing but N1C by NC, N2C by NC, all up to N600C by NC, right? I hope you have got this idea. Let me share you the algorithm of fitting. So let's first set NC equals to 0, NJC equals to 0, where J equals to 1 to 600. Suppose there are 600 features then. So we have initialized this thing. Now for I equals to 1 to n, do something, right? What is n? Total elements. Okay. So total number of items which can be trained. Let's set the C as y's level and nc equals to nc plus 1. So whenever this yi, whatever level it has, so it will be increased, it will be increment in here. nc, what I am saying, see this yi can be y1 2 up to y6, suppose 9000. Okay, there can be uh, we are assuming that there are 9000 uh, items. So and each of the items have some level, suppose 1 2 1 2 anything. Suppose there is binary, then the number will be either 1 or 2, right? And whenever nc equals to nc plus 1, then either n1 is increasing or n2 is increasing based on what is the level of y, right? For j equals to 1 to d, do. What is d? D is the total number of features, right? So for every features we will be, so ij equals to 1, then if the feature is present, then what we need to do, njc is equals to njc plus 1. So we are increasing the feature count by 1, and finally we are finding out pi hat c equals to nc by n. So yeah, this is like n1 by n, n2 by n in case of binary, right? And if there are k number of classes, then it will be up to k. And theta hat jc is nothing but njc by n, right? So theta hat is nothing but a matrix, and this is the probability. Okay, let's meet in next lecture. Bye.